Good morning, guys. We're going to talk today about the layers of the Earth's interior, and we're going to talk about how scientists know if a layer that we've never been to, if it's solid or liquid. So if you look up here, we're going to talk about the melting points of some objects you might find in your house. Now, a soda can is made of aluminum. Its melting point is 1,221 degrees Fahrenheit. That means if I want to melt this aluminum can, I have to get the temperature in my house to 1,221 degrees Fahrenheit. Probably not going to happen. This will always probably on Earth surface remain a solid. If we look at crayons have a melting point of about 120 degrees Fahrenheit. And as my children will tell you, the inside of my car has seen some melted crayons. So that means in the summertime, when the windows are all rolled up, the interior of my car can get to 120 degrees Fahrenheit and melt this crayon that was left by a careless child. Chocolate has a melting point of about 97 degrees Fahrenheit, which is about the same temperature as your hand, which is why candy, chocolate specifically, can melt in your hand. And then we have ice here, or water, which we know has a melting point of 32, and you can see it's warmer than 32 degrees in my house, so it's already starting to melt. So once the temperature is above the melting point of these objects, they will start to melt. So if you look in the asthenosphere, which is my favorite layer, if you go down to the asthenosphere, right here where I've circled, you can see that the black solid line is the actual temperature in the asthenosphere, and this little dash, dash, dash line is the melting point. And you can see that the black line is above the dash line, so that's why in this layer we have some partial melting. Now, what partial melting will look like is this. And this is actually what is happening in the asthenosphere. It's not like it's an ocean and it's completely liquid. It's called the plastic mantle because it's kind of like silly putty and it moves in that same way. If you go over here to the outer core, you can see that, well, here's the temperature, the thick black line in the outer core, and wow, it's way above the dash melting point. So anywhere in the outer core must be liquid. And the outer core we can see here is made of iron and nickel. And if you look down here, the iron, in order for it to melt, it has to be 2,800 degrees Fahrenheit, and nickel has a melting point of about 2,651 degrees Fahrenheit. So that outer core must be pretty dang hot to be above these melting points. And that's how we know that the outer core is liquid and the asthenosphere is partially liquid, kind of like silly putty. All right, get ready for a question, guys. Good job.